You're listening to China Manufacturing Decoded from the Sofeast Group. Hello, episode 289 of the podcast today. Adrian hosting again, and Paul Adams is back after last week. Hi, Paul.
Hello, Adrian. How are you, sir?
Oh, not too bad, thank you. Not too bad. Now, last week, Paul, you were on, and I mentioned that we'd probably get you back on in the next couple of weeks to discuss plastic injection mold tooling and its complexity. And here we are, actually, just 1 week later. So today, you're going to take us on a bit of a journey, right? And part of our business is that we have a whole plastic injection mold tooling fabrication workshop and also injection molding capabilities, many machines actually, for plastic parts for our customers. And what I want to dig into is the journey from kind of starting the DFM, design for manufacturing, on your tooling through to when you can actually start mass production. So what goes into that? What does everybody listening need to be aware of? What's going to, potentially catch them out or surprise them? And, at what point can we actually kind of sign off on our tooling? And then that's where the rubber hits the road and you can start to think about actually producing your plastic parts. So quite a bit to fit in around about half an hour today. And I'm looking forward to this one.
You know me, I tend to ramble on a bit. Please keep an eye on the time, people.
I will.
That's a really good introduction, Adrian. Thanks for that, sir. And always good to be back as a guest onto the podcast, as always. Now, the reason why it's really important to understand the complexity of tooling is that we get asked a lot of questions with respect to why is it my tooling so expensive? It's just a piece of steel. You're just producing plastic parts. So we've done some work on this from a sort of video point of view, but I think it's good to talk about this now, and with respect to what goes into making an injection mold tool and some of the complexities and some of the technology, some of the technical stuff that goes in and around it. And to kick off, you're right. We do start with a DFM. Now, there is a different DFM with respect to starting a project off, with respect to can this product, from a design point be made. So all of that work gets done. We've designed the product. We've done your prototypes, and the prototypes work, and everything's been signed off from a prototype. We then enter another DFM. Now, this is the DFM from a tooling aspect, okay? So all of the design work has been completed on the product itself. So take an individual part, okay? So an individual part needs to be tooled. Now, the DFM will be looking at the wall thicknesses, the draft angles, the gate locations, the ejector placements, and some of the areas with respect to what's really important from a visual aspect, in other words, the A surface and the B surface. What we don't want to be doing is having ejector marks on the A surface, which is the aesthetically pleasing or the aesthetically important side of the molded part itself. So the DFM really looks at all of these. Can we produce the part from the injection mold tool itself, and placement of certain parts of the tool, including the injector placements, including the cooling and the heating and all of the other parts that go into making this complex piece of steel known as the injection mold tool. So your first part is your DFM, which is designed for manufacture. In other words, can we produce a piece of plastic, in other words, the design CAD component in the tool itself?
Yeah.
Okay, so that's step number one, really, which is a different DFM from when we first start. So once that's all done, and obviously this goes through a design review and make sure that you as a customer are involved in that process and make sure you understand what you're looking at. If you don't understand anything, please go back to the mold maker or your project manager or whoever your point of contact is and ask the questions, because they will be more than happy to explain exactly what all of these different colors mean and all of the different angles and stuff like this. So if you're not sure, please ask. So once that's all done and signed off, okay, we then need to go into the design of the tool itself. And we're talking about there's two sections to, two main sections to a mold tool. There's the outside part, which is generally known as the bolster set, and the inside part, which is the core and cavity. Okay, and the core and cavity is the sort of the parts that the steel parts that produce your actually plastic parts. Okay, so this is where a lot of the time and effort goes into when we get into the machining and fitting, which I'll come on to in a minute. So the next section, once we've got the DFM done, is going to the tooling design. And again, once that design has been completed, that'll go through a review. And again, as a customer, you should get visibility of that tool design and a report with respect to, okay, this is what the tool is going to look like, and the specification of the steels. Okay, so once that's done, we then move on to the next section, which is the material procurement. Okay, this generally means that we're actually buying in the different steels. Okay, we're also buying in all of the other components that go into an injection mold tool itself. Now, it's not just two pieces of steel going in and out, in and out. There has to be something like 150 different components that go into making up a single injection mold tool. That might be a little bit of an exaggeration, but what I'm saying is there's an awful lot of components that go into a steel injection mold tool. It's not just the two parts going in and out in the injection mold machine. And this is where the complexity comes in. You've got maybe on a large component, and a complex component with different contours and shapes and curves, you may have something like 50 or 60 ejector pins alone. So, for that side of it alone is a very complex piece of mechanism within the internal working part of the injection mold tool itself. Okay, so this is a really important aspect to understand, and this does take time. Okay, so I'm not going to go into how long it takes to actually create a injection mold tool, because the answer is depends on the size and the complexity.
Sure.
Okay? But the procurement, what we try and do, certainly within our facility, Adrian, is to go with standard components versus custom components. If you got standard components, in other words, there's a brochure of runner systems. So let's order the standard components there, and let's order the standard set of steels that are available. We use our sort of commonly known or used steels within our local area, within China and Dongguan. Okay, this is what we're purchasing. If we need to go customize, in other words, if we need to go and buy custom hot runner that only is made in Germany and they need to ship that from Germany, well, that's going to add 2 or 3 weeks to just the procurement time itself. Okay, so try, where possible, to stick with standard components when you're moving forward in the procurement stage of getting all of the parts in for the injection mold tool itself. The next part is the fun part. As an engineer, this is like, this is where we can start to make stuff. Okay, so we've purchased all of the steel. Okay, we've purchased all of the other components. Now, as long as you've got the steel coming in, the other parts can come along, because we can do things in parallel during this particular stage. And this is where we start to do the machining. Okay, really, we will start with CNC roughing out. I'm basically going to talk about the core and cavity for the moment. The bolster part is a whole different thing, but let's focus on the core and cavity, which is basically going to produce your actual molded part at the end of the day. So we generally start off on CNC. We've got a 5-axis or a couple of 5-axis CNC machines in our plant. This is where we're roughing out the shape of the core and the cavity. From there, we will also be machining brass inserts for the EDM machine. Now, EDM is electro discharge machining, where this is commonly known as the sparky road. So if you ever see it, we've got some videos of this we can sort of put on the website, is as the copper part or the brass part comes down onto the steel itself, there's electric current going through between them and making a spark. That spark is actually eroding the steel and the shape of the insert itself. So we're actually sparking out a very detailed shape. Okay? That's the EDM side. We've also got some wire cutting, grinding, and then we go into polishing, and ultimately we're fitting everything together. Now, before we do the fitting, we do the surface finishing from a hand polishing point of view. We've got two very, very skilled people within our plant that do this day in, day out. And absolutely, some of the surface finishes they get like a mirror finish on some of these things. Fantastic, really good. So we got all of the components ready. We got the core and cavity done to what we call a metal safe condition. Okay. And I'll explain that as we go through sort of the further sections further on. But it will basically produce the core and cavity in a metal safe condition. We then do the assembly and fitting of the tool itself. Okay, so the overall tool is produced, the core and cavity is in there, we bolted everything up, and it's now time to see if it works. Now, this is where things start to get a little bit interesting, and some customers get a bit lost in this particular stage. They think that, okay, because the tool's finished, we should go straight into mass production. So, which is not necessarily the case. Okay. Initially, we will do what we call a T0 or a trial run. Now, the T0 means we are going to load that brand new injection mold tool into a mold machine, injection mold machine, and we're going to run it for the first time. Okay. To start with, we'll run it dry. In other words, does it open and close correctly? Do all of the ejector pins move smoothly? Even try to say that again.
Easy for you to say.
Yeah, exactly. I tried. Does everything work as it should do? All of the lifters, all of the ejector pins, and basically we're just trying to make sure that everything is functioning and moving as it should do. We then start to introduce some polymer. Now, at this stage, could be for sure, is going to be the material or polymer intent for production, but it could include a load of like regrinds and stuff like this. We don't really want to be running virgin polymer through just to try this. So we generally run a lot of regrinds and reusable or recycled polymer for this. And the idea here is to make sure that we can tune in all the parameters from a heating point of view, from an injection time point of view, from a holding pattern point of view, all of the different parameters that go into getting a completed molded part out of the tool and see how that goes. Okay. In other words, you can't really use these parts, but it's going to be the first time you see your particular product coming out of an injection mold tool itself. Okay. Now, we know there are going to be some dimensional errors because we've made the tool what we call steel or metal safe. So where we know that we're potentially going to be tweaking dimensions, getting some dimensions into tolerance, this is where we take the tool out of the machine. We make those adjustments, and some of these could be big adjustments, by the way. We could see that the gate is in the totally wrong position, and we're getting short shots all of the time, or a weld line in a really bad position, and it's really not running correctly. So we could actually make some rather large adjustments to the tool itself, but this is the time to do it. Okay, so all of the big changes and adjustments are made from or after the T0 trial run. Once those adjustments have been made, we then put the tool back into the injection mold machine, and we will run the correct polymer. In other words, we get rid of all the regrinds, and we will use virgin material, and we will pump these sort of products out, and maybe we'll be producing 10, 15, 20 units just from a look-see point of view. Now, this is known as T1. In other words, the first trial of the tool that can actually produce parts that could be checked from a dimensional and aesthetics point of view. So this is different from T0. T0, there's no way you could use the parts from there because we were just testing to make sure the tool's okay. Right?
Yeah.
T1 is we are checking now for dimensional accuracy because we know the tool works. Okay, so we're now focused on the actual part itself. And this is T1. So these would go through the inspection process and a report produced, and it's going to be clear that it's going to be a T1 or the first trial that is usable from a component point of view. And you as a customer should be able to see that initial sample inspection report or first article inspection report or whatever terminology your particular injection mold partner is using. But you should be able to see the specification from the part, in other words, the dimensions, and from the specification and the resultant measured dimensions against each spec. From there, we still expect some minor changes. Maybe there's one or two little tweaks remaining, but nothing serious. If your product requires surface texture, this is where we will be adding that surface texture. So we've finished T1. Okay. The report has gone out to the customer. The customer's come back and says, yes, this is okay. Correct this in tolerance. This one's out of tolerance. You need to adjust that and bring that back into tolerance. Oh, by the way, this one's out of tolerance, but it's okay. So we'll change the specification. Don't forget, it's really, really important that if you sign off a dimension that is outside of specification, you or get the designer to update the specification on the drawing. No. So this is really important because next time round, when it goes round for inspection, you've signed it off, but you didn't update the data. So the inspection team are checking against the original set of data points.
Right. And that's going to go. That's going to go in your live document. That's yeah.
Yes, yeah, and that will come down as a failure or as out of specification. You say, hold on a minute, I signed that one off. Yes, you did, but it didn't change the specification back to the new, now acceptable tolerance range. So it's important that sort of that is done. So anyway, texturing, surface texturing is where we look at adding the surface texture between T1 and T2. Okay, so at T2, we're going to put the tool back into the mold, and this should be, in theory, the final parts. Okay, because we've done the final tuning on any of the dimensions. We've now put in the surface texturing or modified sort of mirror finish to super mirror finish or whatever the case may be, and we're going to be running T2. And this is where we're aiming to sign off the tools.
So,
sorry, go on, Adrian.
So, thinking back to last week when we discussed phase gates, is this going to be your phase gate before you can actually give the green light and go into production then?
This is one of those documents that is needed within that phase gate between tooling and mass production.
Yeah.
Absolutely hit the nail on the head. Yes, indeed. Because you could have 10 different sort of components, whatever the case may be, plastic components come out of your suite of tools. Each of those components will, assuming that we've got one part per tool. Okay, so we've got 10 tools. Each tool has to be signed off. In other words, the component itself produced from the injection mold tool has to go through not just the tolerance check, it needs to go through the aesthetics check. In other words, surface finish.
Yep.
It needs to go through the color check. Make sure everything's consistent. If you've got a purple product or a black product or a white product, brown product, whatever, it doesn't matter. If they're all going together and all slightly a different shade, it's not going to look brilliant.
No.
Okay. That may be, if you're doing some product that does require that, some camouflage, maybe perfect. But assume, right, that all of the parts need to be the same color. Again, this is part of the sign-off. This is part of what we would call the golden sample. Okay. So for T2, it's important that we spend quite a bit of time during this particular T2 period or phase or whatever. No, it's not a phase, it's a period where generally we say to the customer, if we're doing the tooling in this case, it's really a good idea, Mr. Customer or the customer, to come over to China, to your mold maker, and spend time at the end of this tooling phase so you are there, so you can put your fingers on, so you can feel it, so you can touch it, so you can look at it firsthand. Because I know, right, that if I take a photograph with one of my phones, right, and take another photograph with another phone, the color's going to look different. Okay?
Yep. And in different lighting conditions, in one room or another, different time of day. No, you're absolutely right. I mean, I've seen our customers there live with you in the injection molding facility, literally holding up parts that have just come off the press and looking at them in the bright light to check, color and finishes, just like what you're saying. And you're absolutely right. There's no alternative for physically doing that.
It's being on the ground it saves so much time. Okay. Can you imagine if you say, well, no, sorry, but in some cases it's very, very legitimate. You can't physically come over to China for whatever reason. There's no problems. But in this case, right, don't rush the sign-off process.
Yeah.
Get your part sent to you with the inspection report. You need to get more than one component sent over. Say get 2 or 3 of each part sent to you, so you've got a variability from a color point of view. Well, hopefully not too much variability, but you've got something to compare. Okay, get your black marker pen out, sign it, or mark up what's not acceptable, right? Because this is what's needed, even if this is no good because it's got too many black dots or too many scratches or too many defects in one particular area. Mark it up. Okay, make sure that's very, very evident, because that would be, believe it or not, your golden sample.
Yes.
Now, it's more like a limit golden sample, because if it's got too many marks, well, this is the limit. So you cannot, this is a reject. Anything better than that is okay. Okay. This is the time where we need to spend quite a bit of time going through this process, identifying all of these minor little defects that would be our limit samples and our golden sample from every single component that comes out of your injection mold tool. Okay. Don't forget, T2 is where you are signing off your tool suite. In other words, signing off your tooling, and you're also signing that check to pay for the final balance.
Yeah, absolutely. And this is a key learning from this episode, because in terms of managing expectations, right, it might be tempting to say, right, we got the tooling made, it's all assembled, let's go, let's do this. The tangible tooling is there, let's start producing. But actually what we need to understand is that this T0 to T2 process, it's extremely important, but also potentially fairly lengthy, and for good reason. So yeah, from a expectation management perspective, really good to know about this.
It is, and as you say, it's like, oh, we've got the tool ready now, let's go to mass production. Well, no, hold on. So, let's slow down a little bit here and sort of make some sensible decisions, because if you get it wrong and you go to mass production, and we're pumping out hundreds, if not thousands in some cases, of plastic components that go into your assembly, and everything's wrong.
Yep.
That's a really expensive mistake.
Absolutely. And this scenario rears its head throughout the new product introduction process. prototypes as well, product prototypes. Customers, they get a good prototype in their hands and they're like, oh, the prototype's here, great, right, let's go into manufacturing. But actually, as we know, there's heaps to do before that can happen.
There is
So it's the
absolutely,
same
and that's
principle.
it's exactly the same principle. And going back to last week's episode, we were talking about phase gates and making sure that go through that traffic light system. Exactly the same here.
Yeah.
Now, going from T0 to T1 to T2, if you get it wrong, that's fine, because there's always T3, T4, T5. Okay, there's always time. Let's say, he says flippantly, but now's the time. Let's
Yes.
say, to make these changes. That's a better
Yeah.
way to put it.
Yes.
Instead of like making that, let's rush. I want to go, yeah, come on, let's go to mass production straight away. I don't care. It's like, yeah, that'll be all right. I'm sure it will. I'm going to sign it off. Let's go.
Yeah.
Could be a very costly mistake just by rushing. Maybe a week. Maybe a week. It's
Absolutely.
really, really important. So, anyway, the T0 to T2 is generally that set of gates, let's say, that we need to look at each of these different elements from a trial point of view and get to T2. And hopefully, if everything's gone to plan, T2 is where we're going to be signing off the tool. Now, things don't quite work like I just said. There is room for T4, T5, but the key thing is, don't sign off. Please, please, please don't sign off until that tooling is correct. In other words, your plastic parts are coming out exactly as you need them, consistently. Okay? Consistently from a dimensional point of view, consistently from a color point of view, and all of the other defects from a surface point of view. Okay, so that's really important. So, assuming that everything's gone okay, we've just signed off our tool. Now is the time that we can go into mass production. Okay, so as we go into mass production, the orders get placed for the quantity of units you're going to be placing for the first batch of sort of production run. But it doesn't stop there. You still need to keep on monitoring the products as they're coming off, and that is every single component within your assembly, particularly from aesthetics point of view, because generally consumer electronics, it's all cased in a plastic part. Okay? So if you're not taking notice batch by batch, and please ask for the inspection reports each time you get a new batch of parts made from your injection molder, get the inspection report, because things do drift, things do change over time. And you've been running for a year or so and you've had a fantastic run and everything's gone absolutely swimmingly, and you're getting orders through the door and you've already done 500,000 shots. Well, please make sure you're still getting consistency, because these tools don't last forever. You will have to go back at some point, and we'll hope for this, because it's a super successful product. If you're running 500,000 or 1,000,000 units, you'll have to get another set of tools. Generally, by that stage, you're on a version 2, version 3 anyway.
Yeah.
So tools don't last forever, but they do have a lifespan. But hopefully, we've now started to understand some of the intricacies and the complexity of what goes into making a simple tool, in some people's words, and what that really entails.
Yeah, it's interesting to look into each phase and also understand the importance of not rushing into mass production, which, as I mentioned, applies to many aspects of the new product introduction process, which, by the way, this particular MPI process, it's something that we follow at Agilian, and we've created a really good guide about that, which I will link to in the show notes. You did mention a video that you made, which goes into probably a bit more detail about this topic. So I will link to that as well. And for further questions about this particular journey of going from the start of, developing your tooling through to actually finally pushing plastic through the machines and getting your parts injection molded, I think that you are on hand. So if the listeners ever have any questions on that, Paul, I know you'll be delighted to have a chat if they've got any queries.
Absolutely. Not a problem at all.
Awesome.
Always happy to answer any questions.
Great. Paul, thank you very much. Good harking back to last week as well with the phase gates. I think that's worth a re-listen to our listeners. And more or less half an hour there, Paul. Gold star.
Well, done a good job this week.
Great.
Let's see if we can pull that back again. Maybe next time.
Excellent. In future, I think that we'll get you on and we'll talk about the different types of polymers that we commonly work with, because if you're listening to this thinking, yeah, I am using tooling and I do need to be making my plastic parts, well, one critical decision is what kind of polymer or polymers you're actually going to be using. So I think diving into that in a bit more detail is going to be helpful as well. So do look out for that in the relatively near future here on the podcast. Thanks everybody for listening. We will be back next week. Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.